If you step outside on a clear, dark night, far away from the blinding glare of city lights, the sky is a masterpiece. You see a chaotic, glittering diamond dust scattered across an infinite sea of black. You might feel small. You might feel a sense of awe. You might think you are looking at the universe in all its boundless, overwhelming glory. But I need to tell you a terrifying secret. Everything you are looking at is a lie. Or at best, it is a magnificent, comforting illusion. Here is the unsettling truth. When you look up at the night sky, you are not seeing the universe. You are barely even seeing our own galactic backyard. Every single star you can see with your naked eye, every constellation your ancestors used to navigate the oceans, every glowing cloud of Boötes. All of it is crammed into a tiny, insignificant bubble right next to us. But it gets worse. When we actually start measuring things, when we begin comparing one scale to another using our most powerful telescopes, we discover a reality that actively mocks human intuition. Almost everything we can see, every star, every galaxy, every cluster of galaxies, the entirety of the observable light in the cosmos, all of it together makes up less than 5% of what actually exists. The universe, you know, is just a tiny, brightly lit room in a dark, sprawling, infinitely large mansion. And the part we can see, it is just a microscopic bubble floating in an ocean of something that might extend forever. Tonight, we are going to go on a journey. We are going to explore a concept that sounds simple, the size of the universe. But I promise you, by the end of this hour, the way you view your life, your problems, and your very existence will be fundamentally and irreversibly altered. You are going to understand not just how incomprehensibly massive the universe is, but why everything humanity has ever achieved is simultaneously mathematically insignificant in the most precious miracle in existence. If you are ready to shatter your ego and leave the comfortable illusion of your daily life behind, let's begin. But be warned, once you truly understand the scale of what is out there, you can never look at the sky the same way again. To understand the incomprehensible, we have to start with something familiar. We have to start with the ground beneath your feet. We have to start with Earth. From the perspective of a human being, Earth is not just big, it is a monster. Our planet is a sphere of rock and iron, measuring roughly 12,742 kilometers across at the equator. Let's try to put that into a human perspective, because numbers on a screen mean nothing to our primate brains. Imagine you decided to walk around the Earth. If you walked at a brisk, steady pace of 5 kilometers per hour without ever stopping for sleep, food, or water, it would take you 345 days of continuous, agonizing forward motion just to circle it once. If you walked a normal 8 hours a day, you'd be walking for almost 3 years. Even with modern technology, the Earth refuses to feel small. If you got into a car and found a perfectly straight highway wrapping around the equator, and you slammed the gas pedal to drive at 100 kilometers per hour nonstop, it would still take you more than 2 full weeks of continuous driving to return to where you started. From where you are sitting right now, Earth feels infinite. There are dense, untamed jungles you will never hack your way through. There are freezing, crushing oceanic trenches deeper than commercial airplanes fly high, places you will never see. There are entire continents, distinct cultures, and vast deserts you might never visit in your lifetime. The sheer, overwhelming physical size of our world is something most people never truly comprehend, because we only ever experience it in tiny, localized, bite-sized pieces. We live our entire lives inside a geographical bubble. But Earth is not a universe. It is not even an independent entity. It is a speck of dust caught in the gravitational web of a much, much larger master. It is time to take our first step backward. Earth sits in a solar system with the 7 other planets, all hopelessly chained to the gravitational pull of a star that is so comically large it defies human logic. Our sun measures about 1,392,000 kilometers across. To visualize this, imagine the Earth is a standard globe sitting on your desk. The sun wouldn't just be a bigger globe. The sun would be a sphere the size of a 2-story house. You could crack the sun open and pour 1.3 million Earths inside of it, and there would still be room to spare. If you wanted to line up Earth's edge to edge straight across the face of the sun, you would need 109 of them just to span the diameter. And remember, this is a star compared to a planet that already takes us years to walk across. But size is not the scariest part of space. The scariest part of space is Space, the emptiness. The distances between these massive objects are staggeringly disproportionate to the objects themselves. Earth sits about 150 million kilometers away from the sun. Astronomers got so tired of writing out all those zeros that they invented a new ruler, the astronomical unit, or AU. The distance from the Earth to the sun is exactly 1 AU. To understand this distance, we can't use cars or walking anymore. We have to use the ultimate speed limit of the universe, the speed of light. Light travels at an agonizingly fast 300,000 kilometers per second. At that speed, you could orbit the Earth 7.5 times in a single second. Yet even at that ultimate speed, light from the sun takes 8 minutes and 20 seconds to sprint across the void and hit your retinas. Think about the profound philosophical implication of that. When you look up at the sun, which you shouldn't do directly, you are not seeing the sun as it is right now. You are looking back in time. You are seeing the sun exactly as it was 8 minutes and 20 seconds ago. If the sun were to magically vanish, pop out of existence this very second, we wouldn't know. The sky would remain bright, the birds would keep singing, and gravity would keep holding us in our orbit for 8 minutes and 20 seconds. Only then would the lights go out and Earth would be flung into the freezing dark. You do not live in the present, you live in the afterglow of the past. As we move outward from the sun, the distances become hostile. Jupiter, the king of the planets, a gas giant so massive it protects Earth by vacuuming up dangerous asteroids, orbits at about 5.2 astronomical units. That is 778 million kilometers away. Light from the sun takes 43 minutes to reach Jupiter. If you were standing on one of Jupiter's moons, the sun would look like a bright, distant star, providing very little heat. Keep zooming out. We pass Saturn and its magnificent rings. We pass Uranus. Finally, we reach Neptune, the frozen, howling blue gas giant, the most distant official planet in our solar system. Neptune sits out in the dark at 30 astronomical units, roughly 4.5 billion kilometers from the sun. At this distance, the sun's light takes 4 hours to arrive. If you were standing on Neptune, the sun would be so far away, it would provide almost no warmth at all. The temperature drops to minus 214 degrees Celsius. It is a quiet, frozen, lonely outpost at the edge of the world. Or is it? For a long time, humanity thought Neptune, or perhaps Pluto, was the edge of our solar system. We thought that once you passed Pluto, you were in interstellar space. We were wrong. We were not even close. The solar system does not end at Neptune. Far, far beyond the planet, stretching out into the inky blackness, lies a region called the Oort cloud. The Oort cloud is a vast spherical shell composed of trillions of icy mountains, comets, and frozen debris that surrounds our entire solar system like a thick, ghostly bubble. It is the true graveyard of the early solar system. While Neptune is 30 astronomical units away, the inner edge of the Oort cloud doesn't even begin until about 2,000 astronomical units. And its outer edge, it extends out to perhaps 100,000 astronomical units from the sun. Let me translate that for you. 100,000 times the distance from the Earth to the sun. That outer edge is about 1.6 light years away. A single light year is the distance light travels in one entire year, about 9.46 trillion kilometers. The Oort cloud is the true undisputed boundary of our sun's gravitational empire. It is the absolute limit where objects are still just barely loosely tethered to our star before floating away into the interstellar abyss. And here is the most staggering realization about the Oort cloud. It extends almost halfway to the nearest star. Our solar system isn't a tight little family of planets. It is a massive, sprawling, lonely empire of ice that reaches halfway across the void to shake hands with the next star system over. We have reached the edge of our home. Now we have to look across the street. The nearest star to our sun is Proxima Centauri, a small, dim red dwarf that is part of a triple star system called Alpha Centauri. Proxima Centauri sits about 4.24 light years away. That is roughly 40 trillion kilometers. Our brains are not evolved to process the number 40 trillion. We evolved to count apples, track predators, and measure the distance to the nearest river. To truly feel the terror of this empty space, we need a physical scale model. So let's play a game of imagination. Imagine we shrink the majestic roaring sun, that giant sphere that could hold 1.3 million Earths, down to the exact size of a standard basketball. It is about 24 centimeters across. We place this basketball right in the middle of London. In this drastically shrunken model, whereas Earth would be a microscopic bead just 2 millimeters wide, about the size of a pinhead. And where would we put this pinhead? It wouldn't be sitting next to the basketball. To be perfectly to scale, you would have to take that 2 millimeter pinhead and walk 26 meters away. That is roughly the length of two large city buses lined up end to end. Stand by that pinhead. Look back at the basketball in London. That is the distance from the Earth to the Sun. The space between them is completely, utterly empty. Already the emptiness of space is becoming profoundly uncomfortable. But now comes the real test. We have our Sun in London. Where do we place the nearest star Proxima Centauri in this basketball model? Do you place the second basketball at the end of the street? Do you place it on the other side of London? Do you place it in Paris? No. To accurately represent the distance to the very closest star in our universe, you would have to take a second basketball, get on an airplane, fly across the entire Atlantic Ocean, and place it somewhere in New York City, nearly 7,000 kilometers away. Think about that. Let it sink in and break your perception of reality. Two basketballs, one in London, one in New York. And between them, absolutely nothing. No planets, no air, no light. No. Just an ocean of crushing, freezing, radiation-filled nothingness. And remember, Proxima Centauri is our closest neighbor. This is as tightly packed as stars get in our neighborhood. Most stars are much, much farther apart than that. If you wanted to fly to Proxima Centauri in a commercial jetliner, cruising at 900 kilometers per hour, you wouldn't get there in a lifetime. You wouldn't get there in 1,000 lifetimes. The journey would take you roughly 5 million years. Even Voyager 1, the fastest machine humanity has ever built, and launched into the cosmos, traveling at a blistering 61,000 kilometers per hour, would take 73,000 years to reach Proxima Centauri. That is longer than recorded human history. It is longer than agriculture has existed. This is the first true terrifying scale we must accept. Stars are essentially isolated islands, separated by distances so incomprehensibly vast that even light, the fastest phenomenon allowed by the laws of physics, takes years to drag itself from one star to another. We have established that the distance between just two stars is an abyss. But our sun is not just one of two stars. It is one of hundreds of billions. Let's zoom out again. Welcome to your cosmic hometown, the Milky Way galaxy. The Milky Way is a barred spiral galaxy, a majestic swirling whirlpool of gravity, gas, dust, and starlight. It contains somewhere between 100 billion and 400 billion stars. Why such a huge margin of error? Because counting stars when you are stuck inside the galaxy is incredibly difficult. It's exactly like standing in the middle of a dense, overgrown forest and trying to count every single tree. The trees closest to you block your view of the forest edge, and the thick clouds of galactic dust obscure the stars on the other side of the galaxy. But the exact number doesn't matter. What matters is the scale. The Milky Way measures an astonishing 100,000 light-years across. Remember our basketball model? If the distance from London to New York represents the gap between just two stars, try to imagine multiplying that gap billions of times over. If you could somehow view the galaxy edge on, it would look like a bright, flat disk, relatively thin, only about 1,000 light-years thick, with a brilliant, swollen bulge in the very center where ancient stars are packed tightly together around a supermassive black hole. So where are we in this glowing metropolis? We are nowhere near the center. We don't have VIP seats. Our solar system sits comfortably out in the suburbs, about 26,000 light-years from the galactic core. We reside in a relatively quiet, calm region between two major spiral arms in a smaller branch known as the Orion Spur. And just like Earth orbits the Sun, our entire solar system is currently in orbit around the center of the Milky Way. We are moving fast. Our sun is dragging us through interstellar space at a staggering speed of 828,000 kilometers per hour. But because the Milky Way is so mind-numbingly massive, even at a speed of nearly 1,000,000 kilometers an hour, it takes our solar system about 225 million years to complete a single orbit around the galaxy. This is known as a galactic year. Think about the timeline of Earth in the context of a galactic year. The last time our sun was in this exact position in the Milky Way, it was 225 million years ago. What was happening on Earth, humans didn't exist. Mammals didn't exist. The iconic dinosaurs like T-Rex and Stegosaurus hadn't even evolved yet. Earth was in the early Triassic period. The continents you know today, North America, Africa, Asia, did not exist. All landmass on Earth was mashed together into a single massive supercontinent called Pangaea. The Earth has literally drifted through the cosmos, circumnavigated an entire galaxy, while life on its surface mutated, went extinct, and evolved from prehistoric reptiles into apes that build telescopes. Take a deep breath. Look at the galaxy on your screen. Hundreds of billions of stars, each one separated by light years of crushing emptiness. Countless billions of planets orbiting those stars bathed in alien sunlight. From the scale of a human being, the Milky Way represents an infinity we could never hope to conquer. It is the pinnacle of scale. It is everything. Right, wrong. The Milky Way is not the universe. The Milky Way is just a single grain of glowing sand on a beach that stretches out into the dark. The illusion of your size has been shattered. But the true horror and the true beauty of the universe hasn't even begun. We need to go bigger. Our galaxy is not alone floating in the void. It is part of a gravitationally bound family called the local group. This group contains about 50 galaxies. Most of them are tiny misshapen dwarf galaxies buzzing around like fireflies. But there are three heavyweights in this cosmic arena: our Milky Way, the Triangulum Galaxy, and the undisputed king of our neighborhood, the Andromeda Galaxy. Andromeda is a monster. It contains roughly 1 trillion stars. It measures about 220,000 light-years across more than double the size of our home. Right now, Andromeda is sitting about 2.5 million light-years away. Let that distance sink in. When you look up at the Andromeda Galaxy through a telescope tonight, the faint smudge of light hitting your eye left that galaxy 2.5 million years ago. It has been traveling through the freezing vacuum of space since before the human species even existed. When that light began its journey, our ancestors were primitive hominids, barely learning how to use stone tools in the plains of Africa. But Andromeda is not staying 2.5 million light-years away. It is coming for us. Driven by the relentless invisible chains of gravity, the Milky Way and Andromeda are currently hurtling toward each other at an apocalyptic speed of 110 kilometers per second. In about 4 billion years, these two colossal empires of stars will collide. But it won't be a violent, fiery explosion like in a Hollywood movie. Because space is so profoundly empty, the stars themselves will almost certainly not hit each other. It is like firing two shotguns at each other from across a football field. The pellets will simply pass through the empty spaces. Instead, it will be a slow, majestic, gravitational dance lasting millions of years. The night sky on Earth, if anything is still alive to see it, will be completely transformed. Andromeda will grow larger and larger until it spans the entire heavens. The two galaxies will tear each other apart with tidal forces, throwing billions of stars out into the dark, before finally merging into one massive, blindingly bright, elliptical supergalaxy. Astronomers have already given it a name: Milkomeda. This is the fate of our local group. But even this grand collision of trillions of stars is just a microscopic event in the grander scheme. Because our local group is not sitting still either, it is being dragged. If we zoom out to a scale that completely breaks the human mind, we find that our local group is just one tiny insignificant cluster on the edge of an unimaginably massive structure. Welcome to the Virgo supercluster, or as astronomers now more accurately map it, Laniakea. Laniakea is a Hawaiian word that translates to immeasurable heaven, and it is a fitting name. This single structure contains an estimated 100,000 galaxies. Each of those 100,000 galaxies contains hundreds of billions of stars. Each of those stars harbors countless planets. Laniakea spans a distance of 520 million light-years across. Let's return to our scale models to try and survive this mental assault. If the entire Milky Way galaxy with its hundreds of billions of stars were shrunk down to the size of a tiny silver dime resting in the palm of your hand, Laniakea would be the size of an entire football field. And that football field is completely filled with 100,000 other dimes, all intricately connected in a flowing cosmic web. But Laniakea is not a static object. It is alive. It is a flowing, moving river of galaxies. Every single galaxy within Laniakea, including our own, is moving. We are flowing through space along glowing filaments like water rushing down a drain. And what is at the bottom of this drain? What is generating a gravitational pull so violently strong that it can drag 100,000 galaxies across hundreds of millions of light-years? Astronomers call it the Great Attractor. The Great Attractor is a gravitational anomaly located roughly 250 million light-years away from Earth. It is pulling the Milky Way and millions of other galaxies toward it at a speed of over 2 million kilometers per hour. What is it? A supermassive black hole, an impossibly dense cluster of galaxies. The terrifying truth is, we don't exactly know. The Great Attractor is hidden in a region of the sky that astronomers call the zone of avoidance. It sits exactly behind the thick, dusty, glowing center of our own Milky Way galaxy. Our own home is blocking our view. We are sitting in a car speeding down a cosmic highway at 2 million kilometers an hour, and the windshield is completely blacked out. We can only feel the engine pulling us forward. Whatever the Great Attractor is, it contains the mass of tens of thousands of galaxies. It is a monster lurking in the dark, and we are falling straight into its maw. You might think that Laniakea is the ultimate limit, but the universe has no respect for our limits. When astronomers look past Laniakea, they find that superclusters are just the building blocks of something even larger. They form cosmic filaments and walls, immense, impossibly long sheets of galaxies stretching across the observable universe. In 2003, we discovered the Sloan Great Wall, a filament of galaxies that stretches 1.37 billion light-years across. It is a cosmic thread so long that it takes light itself over 1 billion years just to travel from one end of it to the other. But even the Sloan Great Wall was dethroned. In 2013, astronomers mapping gamma-ray bursts, the brightest, most violent explosions in the universe, found something that sent shockwaves through the scientific community. They found a concentration of galaxies so massive it shouldn't mathematically exist. It is called the Hercules Corona Borealis Great Wall. This single continuous structure of galaxies stretches across 10 billion light-years of space. Let me repeat that. 10 billion light-years. That is more than 10% of the diameter of the entire observable universe. Why is this terrifying? It is not just because it is big, it is terrifying because it fundamentally breaks our understanding of physics. In cosmology, there is a foundational rule called the cosmological principle. It states that on a large enough scale, the universe should look roughly the same everywhere. It should be uniform. Because the universe is only 8 billion years old, gravity simply has not had enough time since the Big Bang to pull together a structure that is 10 billion light-years across. It is mathematically impossible for something this large to exist. And yet, there it is. It sits in the dark, staring back at us, a monumental cosmic glitch that silently whispers a chilling truth. Our models are incomplete. We do not understand the universe we live in. There are forces, laws, and mechanisms at play that are entirely invisible to human science. But for all the terror of these physics-breaking walls of galaxies, there is something arguably much worse. Between the glowing threads of the cosmic web lie the voids, enormous spherical bubbles of absolutely nothing. The most famous of these is the Boötes Void. Discovered in 1981, the Boötes Void is a spherical region of space measuring roughly 330 million light-years in diameter. To put that in perspective, the Milky Way galaxy could fit across its diameter over 3,000 times. In a normal region of the universe of this size, you would expect to find at least 2,000 massive galaxies. But in the Boötes Void, astronomers have only found about 60. It is a cosmic desert of unimaginable proportions. Let's do another thought experiment. Close your eyes and imagine that Earth was not located in the vibrant, bustling suburbs of the Milky Way. Imagine that by some cruel twist of fate, our solar system was placed dead in the exact center of the Boötes Void. What would our night sky look like? It would be black, completely flawlessly black. You would see our sun, our planets, and perhaps a handful of stars from our immediate isolated dwarf galaxy. But beyond that, nothing. If humanity evolved in the center of the Boötes Void, we would have no idea that the rest of the universe existed. Our telescopes wouldn't see the glowing arms of other galaxies. We wouldn't see the cosmic web. The nearest neighboring galaxy would be so unfathomably far away that we wouldn't have even detected it until the 1960s. For the entirety of human history, philosophers, scientists, and theologians would have looked up at an empty pitch-black void and concluded with absolute certainty that we were the only objects in all of creation. We would believe that the universe was a tiny cold island of a few stars surrounded by an infinite, eternal nothingness. And it makes you wonder, What are we currently not seeing? What voids are we blind to? What is sitting just beyond our own cosmic horizon that we will never ever know about? We have traveled from the Earth to the great walls of galaxies. We have mapped the glowing cities of the cosmos and stared into the abyss of the voids. But remember the horrifying secret I told you at the very beginning of this journey. Everything we have just talked about, the Earth, the Sun, the Oort cloud, the Milky Way, Andromeda Laniakea, the Hercules Corona, Borealis Great Wall, every star that has ever burned, every black hole that has ever spun, every atom of gas and dust that exists in the observable universe. All of it combined makes up less than 5% of the universe. We are not the main characters of reality. We are the glowing debris left over by the real masters of the cosmos. The other 95% of the universe is made of shadows, things we cannot see, touch, smell, or interact with. We call them dark matter and dark energy, and they are the true puppet masters pulling the strings of existence. Let's start with dark matter, which makes up about 27% of the universe. Dark matter is the cosmic scaffolding. It is a mysterious substance that does not emit, absorb, or reflect light. It does not interact with the electromagnetic force at all. If a clump of dark matter were floating right in front of your face right now, you would look right through it. You could wave your hand through it, and you wouldn't feel a thing. We only know it exists because of its gravity. When we look at galaxies spinning, they are spinning so incredibly fast that the gravity from their visible stars is not enough to hold them together. They should fly apart like a merry-go-round spinning out of control, but they don't. They are held together by immense invisible halos of dark matter. The Milky Way is entirely encased in a sphere of dark matter that outweighs our visible stars by 5 to 10 times. Right now, as you sit watching this video, billions of dark matter particles, likely a theoretical particle known as WIMPs, weakly interacting. Massive particles are passing through your screen, through your eyes, through your heart, and through the Earth every single second, completely undetected. We are swimming in a phantom ocean, entirely blind to the water. But dark matter is only 27%. It is a force that pulls things together. The remaining 68% of the universe is something far more sinister. It is a force that is actively trying to destroy the universe. We call it dark energy. In the 1920s, Edwin Hubble discovered that the universe is expanding. The galaxies are moving away from us. For decades, scientists assumed that the collective gravity of all the matter in the universe would eventually act like a brake slowing this expansion down. But in 1998, astronomers made a discovery that won them the Nobel Prize and terrified the scientific community. The expansion is not slowing down. It is speeding up. Some invisible, omnipresent force is baked into the very fabric of empty space, and it acts as a repulsive anti-gravity. It is pushing space apart. And the terrifying part, the more space expands, the more dark energy is created. The more dark energy there is, the faster space expands. It is a runaway train with no brakes. Dark energy is currently ripping the cosmic web apart. It is stretching the distance between galaxies faster and faster. Right now, there are galaxies so far away that the space between us and them is expanding faster than the speed of light. Their light will never ever reach us. They have disappeared from our reality forever. Every single second that ticks by, thousands of galaxies cross this cosmic horizon, blinking out of our observable universe, lost to the eternal dark. We have spent this entire journey trying to comprehend the sheer staggering physical size of the cosmos. The billions of light years, the trillions of galaxies, the invisible forces that dominate us. But spatial scale is only half of the nightmare. There is a dimension much crueler than distance, a dimension that cares nothing for size or mass or humanity's desperate attempts to understand it. The scale of space shattered your ego, but the scale of time will break your heart. We measure our lives in days, months, and years. We celebrate when we survive for a century. We look at human history, the building of the pyramids, the fall of Rome, the invention of the wheel, and we think of it as ancient. We look at the age of the universe, 13.8 billion years since the Big Bang, and our brains categorize it as an eternity. It feels like the universe is old. It feels like the story is in its final chapters. But this is just another illusion. A trick played on us by our incredibly short, fragile primate lifespans. If we truly want to understand the scale of the universe, we have to look forward. We have to abandon the safety of the present moment and travel into deep time. When we calculate the future lifespan of the cosmos, we discover a truth so staggering it almost defies language. The universe is not old. The universe has barely just been born. If the entire lifespan of the cosmos, from its fiery birth to its ultimate freezing death, were compressed into a single human lifespan of 80 years, we are currently living in the first fraction of the first millisecond of the first day. The universe has not even opened its eyes yet, and the future that awaits it is darker, colder, and stranger than anything we have encountered so far. Let's fast forward the clock. Right now, we live in what astrophysicists call the stelliferous era, the era of stars. It is a time of light heat and boundless energy. Clouds of hydrogen gas collapse under gravity to ignite nuclear fusion, giving birth to brilliant suns that light up the cosmic web. But this era comes with an expiration date. Star formation requires fuel. It requires raw, unbound hydrogen and helium gas. And the universe has a finite supply. Every time a star is born, it locks up some of this precious gas. Every time a star dies, it leaves behind dense remnants, white dwarfs, neutron stars, black holes that trap this matter forever. Our own sun has about 5 billion years left. In that time, it will burn through its hydrogen core swell into a monstrous red giant, swallowing Mercury, Venus, and likely Earth in a fiery apocalypse, before shedding its outer layers and shrinking into a faint glowing ember called a white dwarf. But the sun is just a mid-sized star. The true timekeepers of the universe are the red dwarfs. Stars like our closest neighbor, Proxima Centauri, are tiny, cool, and incredibly efficient. They sip their hydrogen fuel so slowly that a single red dwarf can burn for trillions of years. They are the ultimate survivors. But even they are not immortal. Estimates suggest that star formation in the universe will peak and then steadily decline. By about 100 trillion years from now, a timescale roughly 10,000 times longer than the universe has existed so far, the very last star will be born. It will burn for its allotted time, glowing faintly in an increasingly dark cosmos. And then one day it will run out of fuel. The fusion will stop, the light will fade, and for the first time in over 100 trillion years, the universe will go completely pitch black. Welcome to the degenerate era. The stars are dead. The galaxies as we know them have dissolved. The universe is now a sprawling, infinitely expanding graveyard. The only objects left are stellar corpses. White dwarfs slowly cooling down to the background temperature of space, eventually becoming black dwarfs, cold dead spheres of crystallized carbon. Floating diamonds the size of the Earth, shrouded in absolute darkness. There will also be neutron stars, the ultra-dense crushed cores of dead giants and brown dwarfs, the failed stars that never had enough mass to ignite in the first place. Occasionally, by sheer random chance in the dark, two of these dead remnants might collide. A flash of light will briefly illuminate the void, a fleeting supernova before fading away, returning the universe to eternal night. But the universe is not done dying. Even matter itself, the very building blocks of reality, is not permanent. Deep inside the atomic nuclei of these dead stars are protons. And according to our current understanding of physics, protons are likely unstable over unimaginably long time scales. Physicists predict that protons will eventually decay. The half-life of a proton is estimated to be around 10 to the 34th power years. That is a 1 followed by 34 zeros. At this point in time, the dead stars won't just sit there in the dark. They will literally dissolve. The atoms that make up the black dwarfs, the neutron, stars, the floating planets that survived the death of their suns, they will all slowly break apart into radiation and subatomic dust. By the year 10 to the power of 40, a 10 followed by 40 zeros, almost all ordinary matter in the universe will have ceased to exist. The periodic table of elements gone. The concept of chemistry erased. The physical foundation of planets, rocks, and life completely dissolved into a thin freezing mist of stray electrons and positrons. Only one type of macroscopic object will survive this atomic apocalypse: the apex predators of gravity. The universe has now entered the black hole era. Everything else is gone. The universe is now an exponentially expanding, impossibly cold void populated solely by black holes of varying sizes. From stellar mass black holes to the supermassive monsters that once anchored the centers of vibrant galaxies. They drift through the darkness, completely isolated. They have won. They have consumed or outlasted everything else in creation. But remember, in this universe, nothing is forever, not even the monsters. In the 1970s, the brilliant physicist Stephen Hawking made a mathematical discovery that changed cosmology forever. He proved that black holes are not completely black. Due to quantum mechanics operating at the very edge of the event horizon, black holes actually leak. They emit a microscopic, incredibly faint glow known as Hawking radiation. And because they are emitting radiation, they are slowly, agonizingly, slowly losing mass. They are evaporating. How long does it take for a black hole to evaporate? For a black hole the mass of our sun, it would take roughly 10 to the power of 67 years. For a supermassive black hole one with a billion times the mass of the sun, it would take 10 to the 100th power years. A 1 followed by 100 zeros. This number is known as a googol. It is a number so large that if you tried to write it out and you wrote a 0 on every single atom in the observable universe, you would run out of atoms before you finished writing the number. Over this incomprehensible stretch of time, the black holes will slowly shrink. As they get smaller, they evaporate faster and run hotter. In the final moments of its life, after a googol years of silence, a black hole will finally lose the last of its mass. It will end its existence in a blinding flash of high-energy radiation, a spectacular, violent explosion of light. One by one across the infinitely expanding void, the black holes will detonate like cosmic fireworks. Pop, 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 and then the last black hole will evaporate. The last flash of light will fade into the expanding dark. And that is it. The universe enters the dark era. All the stars have burned out. All the matter has decayed. All the black holes have evaporated. The universe will consist of nothing but an incredibly thin, almost infinitely diluted soup of photons and a few elementary particles spreading out and cooling forever. As the expansion driven by dark energy continues, the temperature of the universe will asymptotically approach absolute zero. The particles will be so far apart that they will never interact again. There will be no structure. There will be no complexity. There will be no change. Time itself will essentially lose all meaning because when nothing ever happens, time ceases to function as a measurement. The universe will reach a state of maximum entropy. Energy is spread out as evenly as possible. The machine has completely wound down. This is the ultimate inescapable fate predicted by our current understanding of physics and thermodynamics. It is called the heat death of the universe. It is a terrifying, depressing thought, to look into the far future and see only cold static nothingness. But before you succumb to cosmic nihilism, I need you to understand something incredibly profound about the exact moment in time in which you are alive. Let's rewind the clock from the heat death. Let's come back to the present day. To our universe 13.8 billion years young. Remember dark energy, the force we discussed earlier that is actively ripping the universe apart, causing space itself to expand faster and faster. This expansion has a cruel consequence for anyone living in the distant future. Right now, we can look up and see billions of other galaxies. We can map the cosmic web. We can look at the cosmic microwave background radiation, the faint lingering afterglow of the Big Bang itself. We can trace the entire history of the universe because the evidence is literally shining down on us. But as dark energy accelerates the expansion of space, distant galaxies are being pushed away from us faster than the speed of light. They are crossing the cosmic horizon. Fast forward just 2 trillion years from now. By this time, our Milky Way and the Andromeda galaxy will have long since merged into Milkomeda. The other dwarf galaxies in our local group will have been swallowed up. Our local group will be one massive solitary supergalaxy. But because of dark energy, every single other galaxy in the universe, every supercluster, every filament of the cosmic web will have been pushed beyond the observable horizon. Their light will never reach us again. Imagine a civilization arising on a planet in this future supergalaxy 2 trillion years from now. They will develop intelligence. They will build telescopes. They will look up at the night sky to try and understand their place in the cosmos. What will they see? They will see the stars of their own galaxy. And beyond that, absolute unbroken blackness. They will not see other galaxies. They will not see a cosmic web. The cosmic microwave background radiation will have stretched and faded so completely that it will be entirely undetectable to any technology they could possibly invent. All the evidence of the Big Bang, all the evidence of an expanding universe, all the evidence that they are part of a larger structure will be completely erased. The universe will have actively hidden its own history. These future scientists will look at their data and they will come to a perfectly logical, mathematically sound, and entirely incorrect conclusion. They will believe that their single galaxy is the entire universe and that it has sat there static and unchanging for all eternity. They will have no way of knowing what they missed. We are incredibly, unimaginably lucky. We happen to live in the exact narrow window of cosmic time where the universe is cool enough to support complex biological life, but young enough that the evidence of its grand, spectacular origins hasn't yet been ripped away by dark energy. We live in the golden era of cosmology. We are the privileged few who get to see the grand architecture of reality before the curtains are permanently drawn closed. We have pushed our minds to the absolute limits of physical size and temporal distance. But there is one final boundary we must cross. And to cross it, we have to ask the most dangerous question in all of science: is the universe infinite? We have talked extensively about the observable universe, the 93 billion light-year sphere around Earth, that contains everything whose light has had time to reach us since the Big Bang. But the observable universe is just a horizon. It is a limitation of light speed, not a physical wall. What lies beyond it, current observations by our most advanced satellites suggest that the geometry of the universe is flat. In cosmology, if the universe is perfectly flat, and it is expanding, it means that space almost certainly extends infinitely in all directions. No edges, no borders, no end. If this is true, the implications are so absurd, so fundamentally reality-breaking, that human language struggles to contain them. If the universe is truly infinite and matter is distributed with some degree of randomness throughout it, then a terrifying mathematical paradox emerges. In a finite volume of space, there is only a finite number of ways you can arrange atoms. There are only so many combinations of protons, neutrons, and electrons you can make. If space is infinite, but the ways you can arrange matter are finite, eventually the arrangements have to repeat. This is not science fiction. It is a logical, inescapable consequence of infinity. If you travel far enough into an infinite universe beyond the cosmic horizon, through unimaginable trillions of light years of emptiness, you will eventually find a region of space where the atoms happen to have arranged themselves exactly like they did here. You will find another Milky Way. You will find another solar system. You will find another Earth. And on that Earth, there will be another you, sitting in the exact same chair, wearing the exact same clothes, watching this exact same video, atom for atom identical to the version of you watching right now. In fact, because it is infinite, there are an infinite number of yous. Some of them made different choices today. Some of them are living completely different lives. Some are reading a book instead of watching YouTube. And if our universe isn't infinite, what if the inflation theory of the Big Bang is correct and our universe is just one expanding bubble in an eternally boiling pot of universes? Welcome to the multiverse, a reality where our 93 billion light-year universe is just a single microscopic atom in an endless ocean of other universes, each with potentially different laws of physics, different speeds of light, different dimensions. At this scale, the human mind shatters. We are not just talking about something big. We are talking about levels of infinity stacked on top of other infinities. Mathematicians call them transfinite number sizes of infinity that are genuinely larger than other infinities. It is a scale so overwhelming that it makes the Earth, the Sun, and even the mighty Laniakea supercluster round down to absolutely mathematically zero. And this brings us back to where we started. Back to the basketball in London and the pinhead 26 meters away. Back to the third rock from a very average star. In 1990, the Voyager 1 spacecraft was about 6 billion kilometers away from Earth, speeding toward the edge of the solar system. Before it left our neighborhood forever, the astronomer Carl Sagan convinced NASA to turn the camera around and take one last photograph of our home. In that image, Earth is not a mighty sphere. It is not a world of continents and oceans. It is less than a single pixel. A tiny, fragile, pale blue dot suspended in a sunbeam against the crushing dark of space. When you look at the scale of the universe, the 10 billion light-year walls of galaxies, the endless voids, the trillions of years of heat death, the crushing weight of infinite multiverses, it is so easy to look at that pale blue dot and feel completely, utterly meaningless. It is easy to succumb to cosmic nihilism, To believe that because we are small, we do not matter. That because the universe doesn't care about us, our lives have no significance. But I am here to tell you that this is the wrong conclusion. The vastness of the universe does not render you meaningless. The vastness of the universe is exactly what makes your existence the most breathtaking miracle in reality. Think about what had to happen for you to be sitting here right now. 13.8 billion years ago, the universe exploded into being. For millions of years, there were no stars. Then the first massive suns ignited. They burned furiously and died in spectacular supernova explosions, forging the very first heavy elements in their cores: carbon, oxygen, iron, nitrogen. Those elements were blasted across the void. They drifted through the freezing dark for billions of years. Eventually, they collapsed into a swirling disk of dust and gas around a newborn star. They smashed together to form a rocky planet. That rocky planet happened to be at the exact right distance from its star, not too hot to boil the oceans, not too cold to freeze them solid. In those primordial oceans, through a chemical miracle, we still do not fully understand non-living matter organized itself into something that could replicate. Life began. And for nearly 4 billion years, that life survived. It survived asteroid impacts that vaporized oceans. It survived ice ages that froze the globe. It survived supervolcanoes that blocked out the sun. It evolved. It grew eyes to see the light. It grew lungs to breathe the air. It grew a brain. And then civilization happened. Ancestors who fought survived and reproduced against impossible odds in a universe that is actively hostile to biology. Every single one of your ancestors, tracing back to a single-celled organism in a volcanic vent, lived long enough to pass on their genetic code. An unbroken chain of survival lasting billions of years, culminating in the exact specific arrangement of atoms that is you. You are not separate from the universe. You didn't just arrive here. You grew out of it the same way a leaf grows out of a tree. The iron in your blood, the calcium in your bones, the oxygen in your lungs, it was all forged in the bellows of dying stars. You are literally scientifically atomic stardust. For 13.8 billion years, the universe was blind. It was a vast, sprawling machine of physics and math doing what gravity and thermodynamics dictated, but it had no way to know that it was beautiful. It had no way to understand its own scale. Most of the universe is dead, empty space. Most of matter is locked up in lifeless stars or freezing rocks. But here on this tiny, insignificant pale blue dot, the universe did something extraordinary. The atoms organized themselves into a configuration complex enough to wake up. Consciousness is rare. It might be the rarest phenomenon in all of existence. When you look up at the night sky, you are not just a tiny creature looking at a big universe. You are the universe looking back at itself. You are the cosmos waking up, rubbing its eyes and asking, where did I come from? How big am I? What does this all mean? The universe does not have a built-in meaning. It doesn't hand you a purpose. But that is the ultimate freedom. Because we are the conscious agents of the cosmos. We are the ones who generate meaning. Your relationships, your love, your art, your curiosity, your kindness. They matter precisely because they are so rare against the backdrop of an infinite, unfeeling void. In a universe governed by cold equations and eventual heat, death, a single act of human compassion is a rebellion of staggering proportions. The scale of the universe should humble you. It should remind you that our earthly disputes, our borders, our ego-driven conflicts are microscopic absurdities on the stage of deep time. But it should also elevate you. You are a temporary, impossibly complex, deeply beautiful configuration of stardust. You have been given the greatest gift in reality, the ability to experience it. So look up at the stars tonight. Do not feel small. Feel incredibly, wildly lucky. Because out of an infinite ocean of darkness, out of billions of years of silent cosmic machinery, you get to be the light that understands it. Thank you for coming on this journey with me. The universe is a vast and terrifying place, but navigating it with curious minds makes the dark a little less lonely. If this video changed the way you see the world, please consider subscribing. Leave a comment below with the cosmic fact that broke your brain the most. Share this with someone who needs a shift in perspective. Until next time, keep looking up.